Okay, so chapter 2 is going to start talking about what we call proofs in geometry. And a lot of times when you're writing proofs, you're thinking, why am I writing down all these steps and reasons? Basically, it's to help you develop the part of the mind that would make logical sense out of things and be able to prioritize better. So I like to tell my students, think of it like if you went into a store and they said, hey, this cell phone is the best. And you say, okay, why is it the best? You would want them to back up what they're saying with some facts, some reasons. If they just say, well, because it is, you're probably not going to buy the cell phone. So think of proofs as a way you're trying to convince the reader why this is true. Okay, we're going to take that kind of reasoning and we're going to apply it to math. So before we get into doing actual proofs, we need to talk about some basic properties of equality. And these are things that are just rules of math. You can't really define why that what we're going to write is true. It just is. So the first property of equality is the addition property. And that simply says if you add something to the other side, or to one side, as long as you add that same thing to the other side of the equation, it is still balanced. So if, let's say, A equals B, then A plus 3 has to equal B plus 3. I have to add 3 to both sides. So that we can kind of visualize what's going to happen with the other properties here. So subtraction property is the same idea, except it says if you subtract from one side, you must subtract from the other. And as long as you subtract the same number, you're going to stay balanced. Your equation is still going to be equal. And we have the multiplication property. Same thing, just this time it's multiplication. So for example, if A equals B, then A times 3 equals B times 3. And then we have division. So as long as we divide by the same thing on both sides of an equation, it will still remain balanced. Now the next three properties could be new because we don't really talk about them very much outside of geometry. But the first one is the reflexive property. And it seems like a useless property at first, but when we start getting into writing proofs in chapter 4 with triangles, it's going to make sense why we need the reflexive property. So that's just saying that something equals itself. So A is equal to itself. Or the distance from x to p is the same as the distance from p to x. It's the same thing. 3 equals 3, 4 equals 4, 6 equals 6. Those are all examples of reflexive property. And then we have symmetric property. And this is kind of an important property. This states that you're allowed to switch sides with your objects. It doesn't matter which side of the equals they're on, as long as they're still saying the same thing. It doesn't matter if I write A equals B or B equals A. They're the exact same thing. And I think that for a lot of high school kids, that concept is really important. And you'll see me a lot of the times, if we're doing a problem and let's say I'm left with 10 equals 2x plus 2. And we're solving that in class. Then I'm going to be like, okay, let's go ahead and subtract 2 from both sides. And then, of course, we'll divide by 2 on both sides. And then I'll write my answer as x equals 4. Well, originally I had 4 equals x, but because of the symmetric property, I can rewrite my answer. I can just flip my equation around, and I'm not changing anything. So for some kids, when I do that, they're thinking, wait, why is x on the left now? Well, because it doesn't matter. It's the same thing. It's not changing what I'm stating. I'm saying 4 is equivalent to x. X represents the number 4. Transitive property we see a couple times throughout the year, and it's kind of hard to explain, so let me erase this here. Basically, in order to apply the transitive property, you need 3 things that are equal to one another. So for example, if we look, A equals B and B equals C. So I see three things that are actually equal to each other. I see A and B and C. Well, in that case, A and C must be the same. So a better way to think of it is, if you can take your information and kind of smush it together in one sentence, so A equals B and B equals C, I can kind of smush those together, and then you can pair up the outside terms. So we'll just pair up these outside terms and say A equals C. Whenever you do that outside pairing, that is applying the transitive property. It states that if two things equal the same thing, then those outside pieces equal each other. It's a little confusing to explain in words. So that will take some getting used to. The last one we have is substitution, and this probably isn't new to you guys. So it just says, hey, as long as two things are equal, whoops, go back here. As long as two things are equal, then you are allowed to replace one object with the other. So for example, A is equal to B. So in this equation down here, 2A plus 3, I can replace A with B because they are equal. And you guys did substitution a little while ago, so that's not really new. So I'm just going to kind of talk about these three properties, specifically the reflexive, symmetric, and transitive. And we more selectively call them properties of congruence. So we'll work with some geometry symbols here. And using the reflexive property, we can state that segment AB is congruent to itself. So I want to write segment BA or segment AB, or I can write segment BA because we said that when you're naming a segment, the order of the letters doesn't matter. It's the same thing. If we look at the symmetric property, remember symmetric means that you are allowed to swap sides and it does not change anything. So segment AB is congruent or the same length as segment CD. Then I can say that segment CD is congruent to segment AB. So swap the signs. You have to remember congruent means same length, so it does kind of symbolize an equal sign. The same thing if I have angle A is congruent to angle B, then I can swap those around and say angle B is congruent to angle A. So we'll kind of apply the transitive property here. So it says AB and CD are the same length. Segments CD and EF are the same length. So I see that this segment CD is congruent to two different things. So I can write out the sentence AB equals CD equals EF. And what that transitive property does is it allows me to pair the outsides together. So I can go ahead and state that segment AB is congruent to segment EF. And if we read the bottom here, I see angle A is congruent to angle B. Angle B is congruent to angle C. So since B is congruent to two different things, those things themselves are congruent. The last property we'll talk about is the distributive property. And that should not be new to us. We know that when you have a letter or a number outside of a pair of parentheses, we're allowed to go ahead and distribute or multiply that letter to whatever is inside the parentheses. And so by the distributive property, I can write that this is the same as AB plus AC. Okay, so we're going to take some of what we wrote and put it to use. So in the first problem, it looks like I'm given this angle, an angle BOC, and I'm told the whole thing is 139. So before, you guys were actually supposed to go through and solve for x in a problem like this. But today, what we're actually doing is the problem is already worked out in steps. And you have to identify a reason for each step. You have to back it up with either a property of equality or a theorem or a postulate. So the first one is involving adding angles together equal a whole angle. And if you don't remember, that was called the angle addition postulate. Now I'm going to abbreviate as angle addit post. So feel free to abbreviate, you don't need to write out all the words. If I look at step 2, I want to figure out what did they do in step 1 to get to step 2. Well, instead of writing angle AOB, they replaced it with x. And instead of writing BOC, they replaced it with 2x plus 10. So another word for either plugging in or replacing is substitution. And then I'm going to look, okay, what did they do to step 2 to get to step 3? Well, it looks like they paired up 2x and 1x to make 3x's, and that's all that changed. And so what that is called, and we'll just write down what we're doing here, and it's combining like terms. Now to go from step 3 to step 4, it looks like they subtracted 10 from both sides. So the good news is, if it involves subtraction, addition, multiplication, or division, we just write that word. So that is the subtraction property. And our last step, it looks like, is they divided by 3 on both sides. So that is the division property. It states that we are allowed to divide as long as we do it to both sides. So you kind of have to visualize is, this is the salesman saying, hey, our cell phone is the best. And these would be your reasons why the cell phone is the best. So you kind of have to see it like that. That's the case, and you have to identify the reasons or find facts that support that. So in number 2, it says we are given that A to C is 21. And so they're starting by adding each piece of the segment together to get the whole thing. And if you don't remember what that's called, just think about they're adding segments together. So we call that the segment addition postulate. And again, we're just going to abbreviate here. And to get from step 1 to step 2, it looks like they are replacing AB with 2y and BC with 3y minus 9. And replacing is really just substitution. Once we did that, we again combined like terms. So I'll tell you what, I'm going to abbreviate it as CLT, combined like terms. Now this time they actually added 9 to both sides, so I want to write the addition property. And we finally, last step is divided, so that would be your division property. All right, example 3 is a little different because we have a vocab word going on in here. And the word is bisect. Now, if you don't remember what bisect means, it means to split into two congruent parts. So I'm going to go ahead and put rainbows in each angle since they are congruent. They're split in half. Now this one starts out a little different. If you notice, they repeated what they gave you information-wise. Since we've been writing just naming steps for this part, we'd like to try to introduce the appropriate way to write a proof. And this is going to sound pretty dumb, but when you write a proof for something or you try to write down your steps and your reasons to each step, you actually always repeat the given information. So we were given this fact, so we should actually be listing that first. So the question is, why do I have to write down what I was given? It's clearly there on paper, blah, 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 blah. That's understandable. The best way I can think of to describe it is communication. There are so many problems that arise in the real world from poor communication. So I think that just kind of restating the facts of what you're given, what is presented to you, is not only a reassurance to yourself, a reminder of what you know, but it also helps you clarify to the reader, hey, I was given this information. We're not just assuming that the reader of the problem knows that. We're actually stating it for them. So after we repeat our given information, we're going to go ahead and say these angles are congruent. Those are the angles that we put rainbows in. The question is, why can we put rainbows in? And the answer to that question would be this word right here, bisect. Bisect means to split in half. So a half is going to equal the other half. It's going to always happen. So if you did not know what bisect meant, you could not do this problem. So that kind of lets you know that you're going to have to include the word bisect in your reason. So we're going to write definition, which I kind of abbreviate as def-n. And we will write bisect here. So I know that these two pieces are the same because I know what the definition of bisect is. By that definition, I am allowed to mark those as congruent. So what are we doing after that? Well, it looks like we are replacing. Right? This says the measure of angle MLN. Well, we're told that's 4x, so we're replacing it. So that would be substitution. And then it looks like they subtracted 2x from both sides. So there's our subtraction property coming in again. And you'll start to see me get lazy with these words a little bit. I'm going to start abbreviating a lot of things. And then our last step looks like division. All right, so let's just kind of summarize each of the 4 big properties that we talked about. When something equals itself, that is called the reflexive property. Part B looks like we added 8 to both sides. That's the addition property. If we look at C, that looks like one of those weird things, RSTW, TW, PQ. So we can pair up the outsides together, and that was the transitive property. The last one looks like angle A equals angle B, then angle B equals angle A. So they have swapped sides, and that is called symmetric property. So what are we gaining from this? Well, we're learning a couple things. When you write proofs, you need a statements column and you need a reasons column. And the statements are going to be you basically solving through the problem, simplifying the problem, and the reasons would be the theorems, the postulates, or the properties of equality that allow you to make those statements. So if we look back through here quick, this is our statement side, this is our reason side. We are going through and actually solving the problem and showing our steps, but then we're also giving the reason for each step. Same as before, statements, reasons. The good news is this always stays consistent. Statements are always on the left, reasons are on the right, and we're going to be doing a lot of proofs this year, so you're going to get very, very comfortable with that.